Okay, in our last video we learned about the trigonometric ratios sine, cosine, and tangent, and we used those trig ratios to solve some different problems involving right triangles. Now, when solving a problem in which we're looking for a side of a triangle, which is the types of problems we solved in the last video, you set up the problem using a trig ratio, that is sine, cosine, or tangent, and then you solve the problem using a proportion. All right, so here's an example of a problem like those we solved in the last video. I've got a right triangle, and I'm looking for the length of this side of the right triangle, the hypotenuse. So I'm going to set up the problem using one of my trig ratios, and the first thing I have to do is decide which of my trig ratios do I want to use. So for this right triangle, the information I have is I have this angle, I have the opposite side, and I'm looking for the hypotenuse. So I want the trig ratio that has a ratio between the opposite side and the hypotenuse. Well, that happens to be the sine ratio. Sine is equal to opposite over hypotenuse. So I'm going to use the sine trig ratio to solve this problem. So I write this down, and then I need to fill in the information that I have for this particular triangle. So the sine of what angle, 27, equals opposite is 4, and hypotenuse is x. So now I have an equation that I can solve, and the next thing I want to do is I want to calculate the value of sine 27 using my calculator. So I make sure I'm in degree mode. Yes, I'm in degree mode. Sine of 27 is 0.45399. Let me put this over here. 0.45399. So that equals 4 over x. And I'm going to put this over 1 so that it looks like a proportion. I'm going to cross multiply. 1 times 4 is 4 equals 0.45399x. And now, my last step, I need to divide both sides by 0.45399. And that's going to cancel out here, and I'm going to be left with, let me write this over here, 4 divided by 0.45399 equals 8.81. So I know the value of x is 8.81. So I have a problem where I'm looking for the length of a side of the triangle. I set up the problem using my trig ratio, and I solve the problem using a proportion. Well, if I'm going to solve a problem in which I'm looking for not a side of a triangle, but an angle of a triangle, I still set up the problem using a trig ratio, just like I did before. However, when I solve this type of problem, I'm going to solve the problem using something called an inverse trig ratio. So let's take a look at what that type of problem looks like. Okay, so example 1a. Here is a triangle in which I'm told the lengths of the sides of 2 of the sides of the triangle, and I'm looking for an angle. All right, so this fits that second category of a problem. I'm solving a problem and I'm looking for the value of this angle. Okay, so I'm going to set this problem up the same way I did before. That is, I'm going to use one of my trig ratios. Well, which one? I have an angle, I know the value of the opposite side, and I know the value of the hypotenuse. Well, sine is opposite over hypotenuse, so that's the trig ratio I'm going to use. Well, again, just like before, I'm going to fill in the values from my triangle. Sine of what angle? I'm looking for the sine of this angle, which is x. Opposite is 3. Hypotenuse is 5. So now I've set up my problem using my trig ratio, but since I'm looking for the angle, I'm going to be using something called the inverse trig ratio to solve this problem. And all the inverse trig ratio is just a way of finding the value of an angle if you know the value of its sine. So, since I know the sine of angle x is 3 over 5, I can find the value of the angle x by using my calculator to find the inverse sine of 3 over 5. And the way I do that, the inverse sine function is the second function right above the sine button on my calculator. So I type in inverse sine of 3 divided by 5. And I hit the enter button, and that tells me that x equals 36.87 degrees. Let's take a look at example 1b. Again, I have a right triangle, and I'm looking for the value of an angle. So I'm going to set this up using one of my trig ratios. So which one? Let's see. I have an angle, adjacent, hypotenuse. Adjacent over hypotenuse is cosine, so I'm going to use my cosine trig ratio. The cosine of x is adjacent over hypotenuse. And again, since I'm looking for an angle, I'm not going to solve this using a proportion. I'm going to solve it using the inverse cosine. So the value of this angle is just the inverse cosine of 5 over 13. So I take my calculator, inverse cosine, 5 divided by 13, and that value is 67.38 degrees. So I just found the value of this angle using my inverse cosine function. Let's take a look at example 1c. I've got a right triangle. Again, I'm looking for the value of this angle. So I want to use one of my trig ratios to set up my problem. Which one? Well, let's see. For this angle, I have my opposite side and I have my adjacent side. Opposite over adjacent is tangent. So I'm going to be using my tangent function. I need to fill in my information here. Tangent of what angle? X equals opposite. Opposite is 10 over adjacent. Adjacent is 24. And again, since I'm looking for my angle, I'm going to use the inverse tangent function. So x equals inverse tangent of 10 over 24. So let's see, inverse tangent of 10 divided by 24. And that gives me 22.62 degrees. All right, one last example of this type, example 1D. Again, I'm looking for an angle. Got a right triangle. I'm going to use one of my trig ratios. Which one? Let's see, I've got an angle, I've got opposite, and I've got hypotenuse. Opposite over hypotenuse is sine. I fill in the information for this triangle. Sine of what angle? X. Opposite is 3. Hypotenuse is 6. And x is equal to the inverse sine of 3 over 6. So I punch that into my calculator. Inverse sine 3 divided by 6 is 30 degrees. Okay, now the main thing that you have to watch for in solving these types of problems using the trig ratio is, are you looking for the side of a triangle or are you looking for the angle of a triangle? Now remember, we're going to be setting up the problems the same way. However, we're going to solve them differently depending on whether we're looking for an angle or a side. If we're looking for a side of a triangle, we're going to solve it using a proportion. If we're looking for an angle of a triangle, we're going to solve it using our inverse trig ratios. So for this example, number 2, I've got a right triangle and I'm looking for the length of a side of a triangle, so I know I'm going to be solving this one using a proportion. So let's see, which one of my trig ratios do I want? For this angle, I have opposite and adjacent. That's going to be my tangent function, because the tangent ratio is defined as opposite over adjacent. So I fill in my numbers for my triangle. Tangent of what angle? 23 degrees equals opposite, which is 12, over adjacent, which is x. Now I want to type in tangent of 23. Tangent 23 degrees is 0.4245. And I'm going to put this over 1 so that it looks like a proportion. I solve a proportion by cross multiplying. 1 times 12 is 12. 0.4245x. Now I need to divide both sides by 0.4245 so that I can get my x by itself. 0.4245. So these cancel, and I'm left with x equals 12 divided by 0.4245, which is 28.27 degrees. Oops, not degrees. I'm not solving for an angle, so my answer is not going to be in degrees. My answer is the length of a side of a triangle. So x is 28.27. Now in example number 3, I am looking for the value of an angle, so my answer is going to be in degrees. I set up this problem the same way using one of my trig ratios, so I have to decide which one. So for this angle, I have opposite and adjacent. So again, I'm going to use my tangent ratio. Tangent is opposite over adjacent. I need to fill in my values here. Tangent of what angle? Angle is x. Opposite is 11. Adjacent is 16. Now, I have my problem set up. Since I'm looking for an angle, I'm not going to use a proportion. I'm going to use my inverse trig ratio. So x is going to be equal to inverse tangent of 11 over 16. So I punch into my calculator, inverse tangent, 11 over 16, and that gives me 34.51 degrees. Now you have a few more examples in your notes. I want you to finish those on your own, and you're going to be doing essentially what we did here. Make sure that you know whether you're looking for the length of a side of a triangle, in which case you're going to solve the problem using a proportion, or the value of an angle of a triangle, in which case you're going to solve the problem using one of your inverse trig ratios. And we'll take a look at these answers tomorrow in class.